Hello, ladies and gentlemen. Today we're going to take a look at making common denominators. So this is a big notes day. This can be a little bit challenging, but I'm going to show you a couple techniques to help you do that. So you're going to need your notes and a pen and pencil for today. Remember, our big objective is we're trying to learn how to simplify these rational expressions accurately, no matter what the operation is. If we're going to add them, subtract them, multiply, divide them, or just simply simplify them, how in the world do we do that? So we're learning the skills necessary. And we've already talked about how important it is when you add or subtract things to be talking about the same thing. So like 3 cows plus 4 cows or 2 cows plus 3 ducks. We know that we have to be talking about the same thing. So we have to make sure that they have common denominators, like terms, whatever you want to call it in algebra. We need to be speaking about the same thing in order to add or subtract them together. So with general fractions, we've already reviewed a little bit of this, but if I had to take 1/5 plus 7/10, we know that these denominators are not the same, so we aren't talking about the same things. 1/5 and 7/10 are not the same denominators, so we need to make them be the same. So what is a common denominator that we could make for a 5 and a 10? Well, we could turn the 5 into a 10 pretty easily, and then he would match. Now, how would we do that? How would we turn a 5 into a 10? Well, I'm hoping you're thinking you just multiply by 2, right? Nobody says you add 5 to make that happen, okay? Because that's not how you make common denominators. Through multiplication is how you make common denominators, not through addition or subtraction. So 5 turns into a 10 by multiplying by 2, not adding 5. So what I do to the denominator here, I must stay the same or consistent and do to the numerator as well. So 1 times 2 then becomes 2. And if we now add, 2/10 plus 7/10 makes 9/10. So I have to have common denominators before I can go ahead and add these fractions together. So now how does this expand to what we're going to do? When we need to add or subtract rational expressions, and they have unlike denominators, ladies and gentlemen, that is, they don't match, we must find the least common denominator, or the lowest common denominator. And we make common denominators by multiplying, never adding things, okay? And so we're going to probably need to use our factoring to make sense of what's happening in the denominators before we can go about making them alike. So this is the big key idea. Make sure you get this part in your notes, and then we're going to do a few examples here with a little organizer to help us. Okay, so here's our first example. Example 1. We have to take 2 over a 3x plus 5 over an x squared. And I'm hoping you're seeing right now that those denominators are not the same. They are unlike. So how do we figure out how to make a like or a common denominator here? Well, I've kind of thought about, and some of my math teachers around me have kind of showed me a little graphic organizer that helps people figure out what their common denominator is going to be. We can't just simply multiply by a 2 or by a 6 or anything to just turn one into the other. So there's a little table I have drawn here up here by this example. And I would do this similar thing if it was in my notes so you can see where we're coming up with this, especially when they get a little bit more complicated. So I have 2 rows in my table there, and that's because I have 2 fractions. So I have a 3x in the denominator of that first fraction. So what I do is I call this fraction 1, and this is fraction 2, and then eventually when you get used to this, you don't really even write those. But fraction 1, tell me the factors or the pieces that are a part of his denominator. So 3x, well, that's both made up of by a 3 being multiplied by an x. Notice how I wrote them separated because they're each part of that factor there, okay? 3 is a factor and x is a factor. Now, what about second fraction here? He has an x squared. But x squared is the same thing as x times x. So fraction 2 has in common an x just like that fraction 1. It's just that he happens to have 2 of them being multiplied by each other, so I'll put another x next door. So notice we can still see what's happening. This is still 3x and this is still x squared. But they're split apart in their factors so that we can help decide what a common denominator should be. Now if we look down every column, we have to have a 3. This is an x column, so we'll call that x. And this is another x column, we'll call that x. So I have a 3 times an x, guys. That means my common denominator has to be 3 and an x squared. This is telling me what my common denominator is. It's 3x squared. So what that tells me in terms of my fractions is that both of those need to have that in the denominator. And once I've established what that common denominator is, then I go ahead and change the numerators to reflect how I've changed that denominator. So I had a 3x here, and now it's become a 3x squared. What happened? Well, we multiplied by another x, obviously, right? So you have to take the numerator and multiply by that x as well. So times x by that 2, what does he become? He becomes 2x then. Now look at the second fraction. We had an x squared already, but now it became 3x squared. So what happened? Well, it must have gotten multiplied by another 3. So we have to change the numerator to reflect that. What's 5 times 3? 15. So we've changed the denominators to be the same using that little graphic organizer, and we've changed the numerators to reflect how we've changed the denominators. And now we have like fractions here that we can go ahead and add. So adding the numerators, 2x plus 15 just becomes 2x plus 15. The denominator stays the same, 3x squared. Now looking to see, is there anything we can simplify? Anything I can do? Is there anything I can do to the numerator here? Can I divide out a 2, a greatest common factor? Nope. So I have to leave him as is. That's my single final answer for adding these two fractions together. Okay, let's take a look at another example. You'll get the hang of this. Let's take a look at another example here. So we have these two fractions, 4x plus 1 over x squared minus 4 plus 3 over an x minus 2. So I know that I have to decide how I'm going to make a common denominator. And common denominators are made by looking at the factors that are happening in the denominator. So the first thing I'm going to think about here is what's in the denominator right here. What pieces would make up an x squared minus 4? That is, what factors does that fraction have in his denominator there? What fraction or factors is down there right now? Like, what's going on? So again, two rows, fraction 1, fraction, oh, little messy, 2, okay, fraction 2, fraction 1. We're going to go ahead and fill in those pieces. So what is x squared minus 4? Well, that's the same thing as x plus 2 and x minus 2. So what fraction 1 has in the denominator really are two factors. One of them is an x plus 2, and the other one is an x minus 2. Okay, I cannot separate those. Those are inside those parentheses, guys. Those are two terms making one factor. So I need to keep them separate. They're two separate things. Now what's going on in the denominator of the second fraction here is we have an x minus 2. So fraction 2, there's no way I can factor that further. You have an x minus 2. Well, that matches what fraction 1 has up here, so I'm just going to write it underneath. We already have an x minus 2 column going on there. So now if I take a look at what we got, we don't have anything else to write to fill in the rest of that chart. The factors have all been laid out there. Fraction 1 has these two factors. Fraction 2 only has this factor, which happens to match with the one on fraction 1. That's why I wrote them right underneath there. And so now we can just say, hey, what is my common denominator going to have? So down the columns, it has to have an x plus 2. It also has to have, this is an x minus 2 column. So it has to have that. And there's nothing else in any of these. So those are the only two pieces that have to be in my common denominator. So now I know I need to change my fractions here to reflect what my common denominator has to be. So it has to have an x plus 2 and an x minus 2. And so does the second one here. And since I've changed those denominators now, I need to reflect the change in the numerator as well. So let's look to our first fraction here. It had an x squared minus 4. Guys, that's the same as x plus 2 and x minus 2, right? So I didn't really change it. I just factored it. I didn't put anything extra down there. So I don't have to change the top at all. But the second fraction, however, just had x minus 2, which means I changed it a little bit. Now look what it has. It has x plus 2 and x minus 2. So I have to put that x plus 2 up on the numerator as well and multiply that out. So it becomes 3x plus 6. Now that I've changed my two fractions here and established my common denominator, I can go ahead and add my like terms. Across the numerators, I have 4x plus 1 plus 3x plus 6. If I add like terms there, I'd have 7x plus 7. X's, numbers, here we go. And then the denominator stays, x plus 2 and x minus 2. Is there anything I can do to the numerator to like factor that out, split it apart a little bit more? Sure, I can take out a 7. But that didn't really help me, huh? Because now when I look at my denominator, yep, no extra factors are going to cancel here. So we'll just leave him like that. That is what he is right here. Final answer. Okay, let's continue on. Here's a third example. Let's go ahead and try to figure out what we got going on here in terms of making our common denominators. So again, I have a little box chart. This is my first fraction. This is my second fraction. We need to decide what factors make up their denominator. So first fraction, I only see an x plus 5. That's all he's got. Okay, x plus 5, factor, you're in there. Now fraction 2, however, looks like he still needs to be factored so we can see what's going on. So what multiplies to make 25 and adds to make 10? 5x and 5x will do that. So if I factor rows and columns here, okay, so looks like the denominator here is x plus 5 and x plus 5. That's what this really is, just in disguise. So now if I was going to lay out what fraction 2 has in my little chart above, he has an x plus 5. I already have an x plus 5 column going here, so I'm going to write one there. But he has another one, so I have to write it next to it as well. I have to start a second x plus 5 column. So that's it, really. Now I just need to figure out what my common denominator is. Well, it looks like I have to have an x plus 5 for this column and another one. That's what the second column says too. So I need two x plus 5 as factors. So my common denominator, here we go. X plus 5s and another x plus 5. Here we go. X plus 5 and another x plus 5. Now I just need to change the numerators to reflect how I changed the denominator. So the first fraction just had one x plus 5. I put another one in the denominator. That means I have to change the top by the same way. So I need to multiply that 4 times another x plus 5. So it becomes 4x plus 20. Now going to my second fraction, I now have x plus 5, x plus 5. What did I have originally? Looks like the same thing, huh? Just in disguise. So I don't have to change the numerator of this one at all. And now I can just simply subtract across the numerators. So 4x plus 20 minus 6x and a minus 1. So let's look at like terms. 4x minus 6x is negative 2x. 20 minus negative 1. Minus a negative is like adding, so that's plus 21. Over my common denominator, x plus 5, x plus 5. Is there anything I can do to the numerator? Like, can I divide out a negative 2 or divide out a negative 3? Not really, so I'll just go ahead and leave him. That's my final answer. Okay, so we're looking at making common denominators here, trying to figure out what's happening in terms of those tables. I have one more example for you and then we're done. Let's go ahead and make common denominators with these two. We have 3 over an x plus 4 plus an 8 over an x minus 3. Let's bring up our chart. Fraction 1, fraction 2. Let's figure out what factors fraction 1 has. Looks like he's already been factored, huh? Just an x plus 4 there. So we'll just say fraction 1, you have an x plus 4. Fraction 2, what do you have? Same sort of deal there, huh? X minus 3. So fraction 2 has an x minus 3. You don't want to write them underneath the x plus 4 because that's the x plus 4 column, okay? We have to start a whole new column because the x minus 3 does not match an x plus 4. So we have those two pieces laid out there. Looks like that's all there is. So my common denominator has to have an x plus 4 and it has to have an x minus 3. So I'm going to change both denominators here to reflect that. X plus 4 x minus 3. X plus 4, x minus 3. And then I'm going to change the numerators to reflect how I changed the denominators. I had an x plus 4 here. I changed it by putting an x minus 3 down there. I have to multiply the top by the same, so it becomes 3x minus 9. Now next fraction, I had the x minus 3, but I put an x plus 4, so I need to also reflect that change on the top, making it 8x plus 32. Now adding my common denominator, or adding my numerators, sorry, leaving my common denominators, x plus 4, x minus 3. We'll go ahead and add. We have 11 x's then, and negative 9 plus 32. Negative 9 plus 32, see those constants there? We'd have a 23. So 11x plus 23 over x plus 4, x minus 3. Wonderful job, ladies and gentlemen. We're going to continue practicing on making our common denominators. Thank you very much for taking good notes.